Hello, Calc students. I'm going to go over section 7.3 on integrating trigonometric equations or functions. If you could turn your class notes packet to page 10, and I'll be talking about integrating products of sines and cosines. There are three cases to consider when integrating products of sine and cosine, and this table gives a nice summary of what that is. So you're going to have combination of sine and cosine. So if one of them is odd, you're going to be splitting off a factor of that particular odd function. So if cosine is odd, you're going to split off a factor of the cosine of x, and then you'll apply the relevant identity, and the identity is from the Pythagorean identity. So it stems from sine squared x plus cosine squared x is equal to 1. And you're going to rewrite it as cosine squared x equals 1 minus sine squared x. And then you'll be making the substitution of u is equal to sine of x. If you have sine that is odd, then you're going to be splitting off a factor of sine of x, and then you'll be using the Pythagorean identity of sine squared x is equal to 1 minus cosine squared x. Then you'll be making the substitution of u is equal to the cosine of x. The third case is when both sine and cosine are even, and we'll get to that on the next page. So let's go through our first example, and this is now relating to evaluating, use one of the three case procedures from the chart. So we have cosine is odd. So you want to first of all rewrite the power that is odd, and you'll rewrite it as keep sine to the fourth x, and then you're going to rewrite cosine to the fifth x as cosine squared x squared, and then you have cosine of x dx. So you're going to be saving this cosine of x dx, and eventually you'll be calling that a du using the u sub. So I'm going to now replace the cosine squared x using the Pythagorean identity, and it's going to be written as integral of sine to the fourth x 1 minus sine squared x squared times cosine of x dx. Okay, I'm going to FOIL this out, 1 minus sine squared x squared. So it's sine to the fourth x, and then you have 1 minus 2 sine squared x plus sine to the fourth x cosine of x dx. Okay, next I'm going to multiply this through, so that gives me integral of sine to the fourth x minus 2 sine to the sixth x plus sine to the eighth x cosine of x dx. Okay, so since I have everything with the power of sine here, I can do a u sub. So my u sub on this will now become u is equal to the sine of x. So du is equal to cosine of x dx. Okay, so now when I make the substitution, I end up with integral u to the fourth minus 2 u to the sixth plus u to the eighth du. Okay, now I'll integrate. So that is 1/5 u to the 5th minus 2/7 u to the 7th plus 1/9 u to the 9th plus c. And then I'll substitute u is equal to sine of x to get my final answer. 1/5 sine to the 5th x minus 2/7 sine to the 7th x plus 1/9 sine to the 9th x plus c. And you can always check to see that this is the right answer by taking this derivative, and then you should get back to this integrand. Okay, let's try the second example. So in the second example, 1b, sine is odd. So I'm going to keep cosine as it is, and then I'll rewrite sine cubed x so that it's sine squared x and a sine x. So it's integral sine squared x times cosine to the 4th x times sine x dx. So this sine x dx will eventually become my du. So the Pythagorean identity I want to use on this is I'm going to keep the cosine to the 4th x, and I want to change the sine squared x to 1 minus cosine squared x. So it'll be integral 1 minus cosine squared x times cosine to the 4th x times sine of x dx. So now multiply that through. So I have cosine to the 4th x minus cosine to the 6th x times sine of x dx. And this time my u sub is going to be cosine of x. Okay, so then you get du is equal to negative sine of x dx. So negative du is equal to sine of x dx. So now do my u sub. So that'll be integral, and so my signs will change since I have a negative there. So it's a negative u to the 4th plus u to the 6th du. Okay, do the integration on that. Negative 1/5 u to the 5th plus 1/7 u to the 7th plus c. And then make u equal cosine of x. Negative 1/5 cosine to the 5th x plus 1/7 cosine to the 7th x plus c. Okay, that's it for page 10.